let me go through a few things. So, brief overview of the 12-volt system. We're going to start with a battery. We, from there, are going to connect the battery to a, what camera am I pointing at here? There we are. I'm going to connect the battery to this, and this switch is 100 amp DC. These switches are extremely inexpensive, but please make sure that if you use them, over amp them very, very generously. This is 100 amps. I would never use it at 100 amps. These Chinese-made switches are unreliable and untrustable at their full amperage. You can tell from just this little bolt here, that is not going to support 100 amps. So please, I would use them at about 50% of their strength, and I would prefer that if I'm using a system that has life dependencies on it, in other words, if you're putting it in an RV or someplace where you're sleeping and you're using your solar system, that you use a different fuse. That you use something more along, I don't have my T-fuse with me. I thought I did. But you use something more along the lines of a T-fuse or something like that. There's a video about the T-fuses, and I'm sure it's linked down below. If it's not, you can find it in my records. But these are good for on-off switches and nothing else. Overweight them extremely good so that they don't burn out on you. All right, so then we go from the battery to the switch. We're going to go from there to a bus bar. From the bus bars, we're going to hook up the inverter. From the bus bars, we're also going to go to a breaker that goes to the charge controller. And from the charge controller, we're going to go to this thing. We're going to go to the solar panels. So, if there are any questions, please don't hesitate to just go ahead and ask. We will be glad to answer any questions, talk to you about anything here. This is not supposed to be me just doing a demonstration. If I wanted to do that, I'd just make a video. If you have interaction, if you have questions, every subject is open around here. So please keep in mind, you're welcome to ask anything you want. And I'm hoping that my help here will wave at me and tell me to help you. All right. So let's look at the other items on the list here. A couple of questions for you guys that might spark a few questions is if you're running a solar system already, if you could just post in the comments what that system is, and I would like to see some feedback about that and discuss a little bit about that. I'm also going to be posting, there's a parts list in the description below. I've already posted it. I will also be sending out a complete diagram later this week of the system that we're going to build here. And I will make sure that that gets sent to the email list. So if you haven't signed up for the email list, go ahead and do that also. I always have all kinds of things there. Now, if you're interested in that, on the Discord channel, I have created a little private area on the Discord channel where I will post things of up and coming, let's call them behind the scenes items of what I did to prepare for today, like all the parts laid out on a table. I painted the board. I pulled the battery and the equipment out of the coffee trailer. And so I pulled some wires, thanks to EG4 and all those EG4 batteries that I bought, because I get to use those wires finally. Isn't that nice? Most of the equipment was stuff I had sitting around, so nothing special there. So let's go a little closer, and I'll just draw up on the whiteboard what we have for a system. So we're going to start with a battery. That's probably not a good color to start with. Neither is that. Let's do it this way. So we'll start with a battery, and on that battery you have a positive post and a negative post. We are going to run that battery through the off-on switch on the positive side, and this is off-on. Wow, that's really bad handwriting. Let me slow down a little bit. the off-on switch, and that will run to a bus bar. Now the bus bars that I've got today are also some cheapies. They are not made for high amperage. They're rated at 200 amps. Keep in mind what I said about all the Chinese stuff that you see on Amazon. Don't trust them for the amperage. Trust them for about half of what they say. These are tin-plated copper bus bars, and everything will screw directly to these. I like these for a lot of little DC connections and stuff like that. They work really well, and they're very inexpensive, which makes them really nice to connect a lot of stuff. So we will run that to the bus bar. The negative side will also run to a bus bar. Now it will run directly to a bus bar. Okay, so then from there, and I want to tell you, I not rehearsed this. This is truly live. I basically laid the components out, made sure all the connectors were going to connect, or most of them. And I am going to be building it and count on your feedback to laugh at me, to throw tomatoes if you need to, and have a little bit of fun with it. That's what the live streams are about, having a little bit of fun. All right, so from there, we are going to go to the inverter. The inverter, I made a mistake on the inverter. I ordered a cheap inverter. I wasn't paying attention, and I didn't get a pure sine wave inverter. Now, let me explain the difference here. A pure sine wave inverter is good, clean energy that comes out of your wall sockets. So when you plug something in, sensitive electronics, let's say a computer, something along those lines, you're going to want this inverter to be pure sine wave. If you were running something simple, like a light, like something like this, which we'll hook up later, or if you're running a hot plate that I'll pull up and show you later that we'll test with. Let me grab it real quick. A hot plate like this. This is just heat induction, nothing fancy equipment. Then you can buy a non-pure sine wave. I still suggest that you buy pure sine wave though. It's very important not to hurt, damage your equipment. Electricity, AC electricity, I should say, bounces from a positive side and a negative side. And it's a nice smooth wave, which is why they call it a pure sine wave. The sine wave is pure up and down, nice and smooth, and I can actually draw this week. Nice. So if you have 0 volts here, AC power will bounce up and down, and it'll go from the 120 positive to the 120 negative, and it'll bounce between those two. And that smooth wave is what those devices are expecting. If you're not running pure sine wave, these will often do all kinds of things. Some of them will do this. Some of them will do this. And that can damage the equipment that you have plugged into it. So it is really important that you ensure you have a pure sine wave. And I know I've gone on this one a little bit, but I wanted to make sure that I stressed it. How important it was to not do what I did, which was buy the wrong one. Now I'll find a good use for it, running something. All right, so from here, we are going to hook up the inverter, and we are going to also set up the charge controller. Now, I want to point out from this point here, I consider a solar system 4 basic components. 1 is your battery, 2 is your inverter, 3 is your charge controller, And your fourth one, which is a mystery. Oh, how about a solar panel? And a solar panel. So these four components are what I refer to when I say a complete system. Now you can add hundreds of other items, off-on switches, bus bar switches, circuit breakers, fuses, electronic tracking devices, a shunt to tell you how much is in the batteries if you have multiple batteries and you're sharing them and you're running in parallel or you're running in the series, or you're running different between 12 volts and 48 volts. So all of these four basic systems are all you need to make it work. So you guys that are in van life or small RVs, you don't need to go all the way to the other end of the spectrum. You can live in this small section here. Now, there is a big difference between equipment. There is really good quality name brand items, like a Victron device. This is great for mobile. There's also bigger, larger equipment, like EG4. And I use that in my RV. I use this in the coffee trailer. And if I was to putting a small system in a van or putting a small system in a really small RV, I would definitely be doing Victron. There is links to all of that down below. Now, the one thing I didn't mention, and I do want to stop and say it here, thanks to all of your support, I got tons of support from the industry this week. I am totally supported by them at this point, and all of the links, all of them, most of the links down below do give me some kind of feedback. All that does not change any of the opinions I have about them because I was using them long before that ever happened. So let that know that I will never tell you something that I don't truly believe or am not using myself. Okay. Just want to check and make sure I haven't missed any comments. Don't think I have. All right. So back to the solar system from here, we will definitely be connecting the charge controller to the bus bars. And so everything that is going to be using the batteries goes to the bus bar. The inverter uses the batteries, it goes to the bus bars. The batteries need to be hooked up to it. And I've got waving telling me I've got a message. So let me just switch over here real quick. And, oh, I got two messages. All right, let's do, oh, that one I already took care of. Okay, let me just send this in and see if I know how to get it to display. Wrong one. Oops, another wrong one. All right, that didn't work. Let's try it this way. I know how to make this work. That button. There we go. Can you salvage parts from UPS? I have several that I have pure sum wave converters. Pure sum wave converters. And you're talking about, can you salvage parts from a UPS? You're talking about a UPS that's from backup power? I'm going to take a look at the chat and see if you have additional feedback for me. Pure sine wave. Okay. All right. I got it. So can you salvage? It's pure sine wave. If the UPS is pure sine wave, and it depends. A UPS is designed to turn on when the power gets shut. So can you use it for the purposes of an inverter? Probably not. You might be able to use it to, if you've got it plugged in and you unplug it, it would switch and the power would come on. I don't know of any way to get it to use a battery because a UPS, so let's say you have a 120 volt plug and you have a UPS plugged in, and then you have coffee pot. Okay, got to draw a coffee pot now. Hey, that's not too bad. Okay, so your coffee pot is going to be using the power that is bypassed through the UPS. And when you lose this power, gets cut here, it's going to pull from the batteries and run the coffee pot. Now, I suppose if you went in and rigamarooed this, that you could get it to work. I'm really not something that I would probably do. That doesn't mean that you can't do it. I'm just not sure that it would be something I would do. I hope that answers your question. If not, send another one and I'll be glad to follow up on it. So back to the system here. Got a follow-up question. All right, I can deal with that. Well, let's go do it. Do you have a send button on your messages? Yeah. Okay. Next time you can just send them and I'll display them. You can take the inverter out and use it. Okay. If you can take the inverter out, if it's an actual separate device, then of course. And you just hook it to whatever battery you're charging. The question is what type of batteries do they have? The batteries that I'm referring to here are these LiFePO₄, these lithium iron phosphate. They're very safe. They don't catch on fire. They don't burn. Some of those YUPS machines have the original lithium batteries. Those are the ones that were famous for catching on fire. They allow you to store a lot more energy in a very condensed space. But they also have thermal runaways, and that's where they were dangerous. When they added the phosphate to the lithium iron batteries, that's what made them so safe. That tamed them down. Now, that doesn't allow you to store as much energy. The density of the storage is reduced a little bit, but the longevity of the battery becomes around. So as opposed to your cell phone, you charge this, a couple years later you start losing capacity. This is a lithium battery. Now, if this was a lithium iron phosphate battery, instead of this battery lasting for 24 hours, it would only last for 12 hours, but it would also last for 12 years, and it wouldn't die, and it would just keep working and working and working. So that's really the difference. Adding that phosphate to those lithium iron phosphate batteries stabilizes it to where it lasts a lot longer, but it decreases the ability for it to store power. So yes, if it's there and the battery is the right kind, you could do that. If the voltage is the same, then you could do that also. Just keep in mind that lithium iron phosphate batteries usually are a bit different in voltage. So for example, a lead acid battery, a standard lead acid battery, is 13.6 volts. A lithium iron phosphate would be 14.4. So if the inverter can handle it, and if you have the right charger to charge 14.4, then yes. Otherwise, you can see there's a lot of different variables here, but hopefully that answers your question. All right. Once we get everything hooked to the bus bars, we are going to make sure that the solar panels get connected to the charge controller. So there are multiple ways to connect solar panels, and I encourage you to go watch a video called Series versus Parallel. And this will basically suggest if you should hook the batteries up, the solar panels up like this, or if they should be hooked up like this. And there's a lot of reasons to do it both ways. And a lot of the charge controllers and those type of things can allow you to determine this is. I won't cover this today. I'm going to assume that it's a 12-volt system. I'm going to hook a single solar panel to this, and the follow-up video that I'm promising, and I'm going to take the solar shed and I am going to redo all of the panels on the top and seal it. And when I do it, I'm going to hook one up to this device, and we're going to test it and see how long it takes to charge and all those things. So that way you'll be able to see all of this in action once we get it hooked up today. Today we're going to hook devices up to it and make sure it runs. But the battery is already sitting at 98, 99%. So that's kind of cheating because I pulled it out of the coffee cart and it was already charged. Okay, or coffee trailer. So as you can see, this is what we're going to be building today. And I think I've taken enough time talking about it. Make sure there wasn't anything else I didn't want to cover. And you guys had some good questions. I appreciate that. There were 3 common mistakes that I wanted to cover for beginners to make sure that we don't make these type of mistakes. And those are the negative and the positive being connected is the most common problem that you're going to run into. It can cause serious damage to your charge controller. Now, fortunately, Victron, knowing us, has made these pretty foolproof, and they do recover most of the time. But please be very, very careful. I'm going to come out with a video here in the next couple of weeks that talk about tools that you absolutely have to have. The number 1 item on that list is one of these multimeters. And what you need to be able to do is determine which side is the positive and the negative. And with DC power, that makes it very, very easy. You can just touch it to the sides, and you can see the power and the voltage right on the screen, and you can ensure that you have it corrected the same way. Same thing's true with the charge controller. When you're hooking things up here, before you flip the breakers, you can check the lines that come in and make sure that you have them hooked up correctly. You can make sure that when they're hooked to the charge converter before you turn it on, that they're connected correctly here. You can double check your inverter before you flip it on at the actual terminals to make sure that it's done. But it is probably one of the most common. I see people hooking up full-fledged house systems, and they complain that they can't get the PV to charge. And I couldn't tell you how many times I've said, did you check the polarity of the positive and the negative on the solar panels? And one of 2 things has happened. They've gotten 2 panels or 2 strings, and they've just got 1 string backwards and they cancel each other out. Or they hook them to the charge controller or the 6000 XP and all-in-one, and it basically is smart enough to say, no, this is backwards, I'm not doing nothing. And it just stops producing, doesn't do anything. So that's number 1. So please make sure you're aware of that and watch for that. Second one, oversized panels versus overpaneling. Now let me explain the difference here. This one gets a lot of people confused, or overvoltage versus overpanel. If your charge converter, for example, supports 200 watts, let's make it easy. It supports 240 watts at 12 volts, which is very simply 20 amps. The same as the one that I have here. The one that we're going to use today for the example. Then you can hook up extra panels and give it, let's say, 300 watts of power from those panels. And at 12 volts, you would have an extra 60 watts, which is roughly an extra 4, and you would have an extra 24 amps. Now, it will not charge at 24 amps. It will do what we call clip. When it clips, it's going to clip it down to 20. But what it does is if you have 0 here and you have 300 watts here, when the power goes up, when it hits the 240 range, it's going to stop and run at that until there's no longer power, and then drop back down at the end of the day. So this window of your max 240 will be extended, but this will not harm your equipment. In 99% of the cases I've ever seen, nothing bad will happen from doing this. Now, this is a very big distinction from overvolting. If this says that it supports 100 volts, which is, this is what that model number means. It's 100 volts and 20 amps. So by that, what it means is it's going to take in 100 volts and output 20 amps, and that's what those numbers represent. Now, with the 100 volts, you cannot go over 100. This one is very, very critical that you get it right. You will burn this device out. And the Victron devices, and this specific one, are sometimes very forgiving. And they may shut off, and they may give you a warning, but 99%, well, I'm going to say 90% of the time that I've ever seen this happen, this burns out. You can overpanel it, but you can't overvolt it. Now, for those of you that are in very cold regions, you need to be aware that panels in cold weather produce more than they do in hot weather. So people misunderstand this all the time. They think that solar works better in hot weather. It doesn't. It works better in bright weather. Has nothing to do with ultraviolet rays. It has nothing to do with it being hot. Actually, the colder it gets, a panel that produces 30 volts at, let's say, 10 degrees Fahrenheit may produce 36 volts at negative 20 degrees Fahrenheit, or maybe even more. So this is something you need to be very alert to, that what I usually suggest is you leave yourself a 20% buffer. In other words, if this supports 100 volts, only run it at 80 volts. And that way you've got a safe enough buffer that you're not going to burn your device out. Okay, that was 2. The third one is oversized panel voltage or oversized. It's the same as the one before. I put notes together for all 3 and I only end up with 2. So those are basically some of the things you need to do. I don't know if there's any questions at this point. I'm going to check real quick. Make sure that if there's any questions before we get on with the build. And let me just see, switch this screen here. And let's see. All right. So let's get on with the build. And if you have questions, please let me know. And I'm going to get right into it here. And we'll go back to the whiteboard and answer any questions or do whatever we need to do that. So let's start with I like to connect the battery last. Now, I think I shut this battery off in the app. And I'm going to tell you, this battery I bought on Amazon. There's a link to it on the list. I actually bought 2 batteries at the same time. And I just bought them for playing around and testing things and doing stuff like this. And they ended up being very good little batteries. So they were very reasonably priced, but they were both 12 volts. So I ended up putting them together and putting them in my coffee trailer. So I think I've got them turned off. I just want to confirm that before we go hooking wires to it and everything. So you can see here with this app, It's sitting at, I'm not sure what screen I'm on. I changed my thing. There we are. You can see here from the app, we're sitting at 98%. And we'll see if we can, and it is turned on. CMOS on. Most of these allow you to control, you can see the two settings here, if the charge is allowed or if the discharge is allowed. So make sure you get Bluetooth when you buy a battery. Don't just buy dummy batteries. Dummy batteries work fine, but these allow you to monitor it without any of the fancy software. All right. I know I'm giving you guys a run for your money over there, keeping up. Thank you. All right, so let's start building. Since that battery is live, let's get an idea. I got these two cables here to connect to the battery. What I want to do is I'm going to connect this first so that I know where I'm going to mount these. And so I'm thinking that if I put the negative on this side where the negative post is and the positive on this side, then I can route these wires down there and we'll leave one of these disconnected until such time that it's done. So let's start off by getting these two bus bars mounted. And then everything else can go above it. So I'm thinking bus bar, maybe a switch over here on the side. The bus bars will then feed the inverter over on this side and the charge inverter or the charge controller up in this corner, and we'll hook the wires up to go to the panels. Shouldn't be that bad. I brought a bucket of parts, if I can find them. Don't know what oh, they're right here at the end of the counter. So as I step out of the scene every now and then, sorry about that, I'm going to grab a little bucket of screws here. These are just typical little Home Depot, Lowe's screws. No big deal. So I will, let's see, what camera am I on here? Way over there. Oh, this one right here. No, this one way over here. So we'll get the, these are just little screws with big, fat, thick heads. I like these thick heads because they really get a hold of things. They really give me a good gripping and hold on to stuff really well. I'm a little paranoid. Being an engineer, I'm always over-engineering my fixing things to stuff. All right, so let's start with the bus bars. And I'm just going to mount them over here on this side, leaving room for that off-on switch, because I do have the off-on switch for the positive and a, what do I have for the negative? Nothing. Okay. So let's just hook this right here. And let's put the other one on. I probably need to throw something behind that so that it doesn't slide. All right, I'm going to lose my microphone too. All right, and then we'll put the second one in here. Try not to over tighten it too much.
Behind it.
Oh, it's already too late. Thank you though. All right, so that's the negative. Let's put the positive one in right now. Then we can do all the wiring. And if you have questions, please feel free to just write them in the message and they'll point them out to me. I'm just going to connect a few things here and I'll walk you through each one of them. So I'm thinking the positive needs to come off of the switch, the off-on switch. So what we can do is we can go ahead and hook up the wires and we can just turn everything off. Now, oddly enough, I noticed on this switch that the battery in is here. Oh, where am I? There I am. The battery in is on this side, and the negative is on this side, and the other buses come on this side, which means I have to mount this upside down. So I'll mount it upside down. I don't know why they did it. Maybe because the normal way of hooking it up, it does it that way. So I'm going to put that switch right here. All right. So now we've got a switch and we've got 2 bus bars. So let's connect the wires, because we have the wires here that go to the battery. Now on the battery post, you can see, I don't know which camera I've got that I could show this on, but these holes are 2 different sizes. So I had this cable already made and I don't know where from. I think when I originally bought these batteries, I made this to hook it up to something. But this is the size of the post on the battery, and this is the side of the post on the bus bar. So they are AUG6 and they're rigid. These are the only rigid ones I have, but I'm going to go ahead and use them because I had the cables already. There's no reason to remake cables like this. These are nice cables. So let's start with the positive, and I'm going to hook this up over here, and I'm going to connect it to the bottom or the battery end of this upside down switch. Now, most of the time, when you hook things up like this, you are going to want to use a torque wrench. And you're going to want to torque them to the right spec. Because the number 1 cause of fires, and I'm going to give you a very, very convincing example of a number 1 cause of fires, is a loose wire. As you can see from this device right here, the negative post, when I hooked this up in the coffee trailer the very first time, I failed to tighten this terminal, and it burnt the plastic off the top before I realized what was going on. And you can see from this, had I not been there, this could have been very, very bad. So when you build a system like this, not only do you want to torque them to the right specs, but you also need to make sure that they are all tightened, and check and recheck. So today, you're not going to see me torque anything, but I'll just give them a good snug tight, and I'm also not going to be using it for anything major, except a few tests that we're going to run. Also, what you want to check when you're building a system like this, if you're putting insulation like this on your wires like I do, as you can see here, I insulate all of my wires with something like this, and it's done with heat shrink. With this little heat gun, you just snip off a piece, you slide it on there. When you do this, you need to make sure that the copper of the connector of the top and the bottom are not in the way of this seating flat and being screwed down flat on the top. That entire connection, top and bottom, is really, really important. Keep in mind that especially a 12-volt battery, if you plug something simple in that's using, let's say, 120 watts, it's going to pull 10 amps out of this. That's half of the amperage that comes from a wall plug at full usage. So please keep in mind, the connection are your number 1 concern and your number 1 cause of failed screw-ups. All right. So we connect that one. We leave this popped so that there's no voltage. Now, this is a perfect example of how you would use a multimeter and when you would start to use a multimeter. So for example here, I could test that this switch is working, and I could turn this on voltage, and I can set it to DC, and I don't know if you can see that. I'll turn that light on so maybe they can zoom in on it. And so if I connect here, you can see that I got 13.3 volts. If I connect here, you'll see that I've got 90, 80, 70 millivolts, which basically means connected to nothing, same as over here. So now if I turn this switch on, now I have 13.3 again, and it's off. More importantly, is the positive side is on this and the negative side is on this. If I hook this up backwards, you will notice the negative symbol right here on the multimeter coming on, telling me that these are backwards. Now, of course, I've got the connectors backwards, so I would expect to see them backwards. But that is one of those key problems that we had before that you need to be aware of. And you need to make sure that at every step in this process, you're checking it and testing it. Be anal about it. I don't know a better word to use other than just be overly cautious, because that mistake you will make. We have all made it. Anyone who's hooked up a solar system, eventually you will make it. The question will be, how bad will the mistake be when it happens? Now, as you can see here, I've got a little bit of insulation, but I don't like the way it's on top of that. So I'm going to cut it off so that I can get a good connection. And now you can see it should be able to seat very well into this battery and lay flatly across there, and this bolt screw down completely flat across it. And then I'm going to tighten it down. And if I had a torque wrench with me, I would torque it to make sure it's correct. Now I'm going to bend this into place, since this is regular regular electrical wire for a house, so I'm just going to bend it where it needs to be and put it here. All right. Now, this bus bar, these screws kind of hang out the back when you disconnect them. So you have to be very careful when you're hooking things like this up, because the pliers themselves, now these are insulated at the end. Many of these only have this insulation, and the ends are exposed. And the last thing you want to do is turn this set of pliers and hit this other terminal. I can tell you, I have seen people who take wrenches and do that, and pliers and do that, and it causes massive short. Now, in our case, I have access to the app where I can go in, and I don't know if you can see this on the, see if we can, you got it? Okay. I'm going to go in here, and I'm going to shut off the battery. And now that this battery is off, as you can see there from these two settings, I'm going to retest the voltage, just because I want to ensure that I don't live on YouTube show you how to short things out. I can teach you a lot of stuff, but that is not going to be one of them. And as you can see, it didn't shut down. Oh, it's a polling voltage. Oh, I forgot about that. Okay, so some of these batteries have what they call polling voltage. They shut off, but they provide a trickle of a milliamp in order to let the voltage show through. You can see that the voltage here is much reduced from the 13.3. It's only 12.6. It's basically a polling voltage to say it's there. If I was to test how much power was there, it would be very little. So I'm going to turn it back on just so we can see the voltage go back up to 13 with it on. And you can see 13.3 there. Now if I could figure out, let's see, do this. There we go, 13.3. And I'm going to shut shut this off while I'm here. Ready, set, go. And wham, there goes the voltage, and you can see it drop down. So most of them will actually shut completely off. They don't have polling voltage. I'm not sure exactly what this is used for, but I imagine it was to allow for detection of what the charge rate was or something along those lines. All right, now we have the battery off, we have the circuit breaker off, we have all the connections below this connected. So let's move on to the next phase. The next phase is we've got the bus bars installed. Let's hook the inverter up. So the inverter, as I said before, came with a couple of connectors. This one allows you to plug it into a cigarette lighter. And if you have a cigarette lighter that can support 1,000 watts, then you have a miracle car, and I've never seen it actually work. It may work for a couple hundred. Doubtful it's going to do that. 120 watts is 10 amps. If you look at most of your cigarette lighters, they blow the fuse at 15. So that means you're not going to get more than 180 watts out of one of these before you blow the cigarette lighter out. And then you're going to blame it on the cigarette lighter, not on your inverter. That ain't going to work. These clips will support a little bit more. And you can clip these directly on the battery. But what you can't do is pull 1,000 watts through them. In order to pull 1,000 watts, you need a good, safe connection. Unless it's just temporarily, unless you're running like a pump to run up a flat tire or something like that. Please do not use those for van life where you're cooking or you're depending upon them or something like that. You will catch things on fire and it'll be a bad day. Okay, so I'm thinking the inverter we mount way over here, and that way the plugs hang off the side out of the way. We put them not too high and not too low. I do have these cables to connect them. So let's see how this would work. Let's just see. Let's take this and just put one of these on. And you can see with all these loose wires hanging around how easily when you're connecting this that you can cause yourself a problem. So this is why you always double, triple, quadruple check to make sure that you're not going to cause yourself to get shocked or shorted out. All right, I'm going to connect this one up and just loosely set it on there. Another thing to note here is when the terminal is connected to a device or a bus or an inverter or anywhere else, the washer never goes between the device and the connector. These two always are bare metal to bare metal. It is very important. Remember that connection is the most important thing that you're worried about. The washer can go on top of that, but it cannot go under it. Going under it causes unnecessary restrictions, unnecessary resistance, and you will basically cause heat and possibly could cause yourself some serious problems later. Oh, that looks really good right about there. So let's take this and put it in right here. And let's take the second one. Gonna kind of balance this and get this in. Put the second one right up here. And I'm going to put a couple of extras because we're going to be plugging things in and plugging things out. And then one more up here at the top. Get my bit back. Then I'm going to go back to this original one and tighten it up. All right. Now I've got a good inverter mounted. It's nice and strong. It's safe. I can tighten these cables here to make sure that they're not going to move. So I'm going to start with this one down here, and normally I would make it point straight up and look really nice, but I'm not going to mess with it for this. I'm just going to give it a good twist, make sure it's nice and tight, make sure it doesn't move. And then I'm going to do the same over here. Make sure it's good and tight, make sure it doesn't move. Okay, said and done. Now let's look at the positive. And let's hope that I left enough room for it to reach. All right, same thing. The washer comes off, the connector goes, then the washer, then the screw. And making sure that everything is flat and connected all the way across. None of the insulation should be in the way. Don't assume that you can tighten it down enough to cause this to not be in the way. It will be in the way, and it's bad news. All right, so we're going to put that there. Oh, this one's going to fit really nice. So we're going to just move this to the far right because we know the other devices have to connect to the left. So let's just put this here. I'll tighten this down. And give this a little bit of a twist. All right, good and tight, good and tight, good and almost good and tight. And this is why you test and retest. Good and tight, good and tight, good and tight, good and tight. Okay, that's good. Now we just need to connect this switch to here, and we should be able to activate the inverter. Now we won't be able to charge it, but we'll at least have the basic flow, and we'll be able to determine if everything's going to work. So I'm just making sure the off switch is off over here. All right. So next, we are going to get another red wire, and we are going to connect the output of this switch, being very careful not to flip it on accident, although we know the battery is off also. You learn to be a little bit respectful of electricity as you've been in this, doing it long enough. And then I'm going to put that on this far side over here, knowing that something's got to run to the charge controller here in a bit. That gives us 2 posts in the middle. I could have technically put them on ends, but the ends are for these little pretty caps. And since I don't need them, I'll leave them nice and pretty. All right, so we'll tighten that down. Give this a good tighten. And I should have like a torque wrench that allows me to twist it and lock it. And this one, tighten it. There we go, there we go. Okay. Now, let's check a few things. Remember I told you how paranoid I am about checking polarity, positive, negative. So you're going to see a little of that here because I really don't want to demonstrate how to short things out. So I'm going to turn this on, reset it so it doesn't shut off in the middle of this demonstration, turn the light on. All right. We are going to turn the oh, you know what? We got testing voltages without anything. So let's just do the testing voltage. Let's just check them. All right, so here we go. 12.69, 12.69, 12.69, and 12.69, which means the negative is good all the way from the inverter down to the bus bar, from the bus bar to the battery. The positive is good from here to the switch. The only other side we have is all this positive over here. So we're going to turn this on. And we're going to check here. Remember, this is still off. And really, there's no power in that battery. And as you can see here, we're down to 400 millivolts because by the time it goes through all these resistance, it doesn't have any power left. You can see there that the power's all gone. All those capacitors are gone. Now I got to turn this battery on. So I'm going to pop this again, turn the battery on. We're going to check it here, 13.3, check it here, 13.3, check it here, 13.3, turn it on, and check it here. Now, when I turned this switch on, it charged a capacitor in here. And you remember when I told you that it was showing that 12.6? That voltage was in the capacitors in here, and when it turned this on, it transferred all that power and they both went dead. There wasn't enough. When I turned it on the second time, that voltage is now there. So if I open this and test it here, that capacitor will have some voltage, and we'll see it drop as I connect this, as it detects it, and it starts draining it. Depending on how big they are, see 0.10, 0.00. So depending on how big those capacitors are, they're not very big in here, but it was big enough to zero out this one, and then when I put the amp meter on there, it pulls a little bit of power. I'm talking millivolts, but it was enough to drain the capacitors here. All right. Everything seems to be working. Everything seems to be okay. So the next item is to turn this on. And as you can see, we have success. This is now pulling from the battery, running the inverter. We don't have any load. And just to confirm that, we're going to come over here to the battery app, and I'm going to show you the usage right here on the screen. And this is the benefit of using the Bluetooth batteries, because even though this is a cheap battery, and I'm talking $130, maybe $140, and it's already been cycled 50, 60 times. Actually, the cycles may even be on the screen, 37 times. It's been in the food trailer, the coffee trailer, for 9 months or so, 8 months. But you can see here I've got 0 usage. Now, to show you that in use, I brought us a light. And I did this intentionally to mess with the camera guys. No, I didn't really. I just thought about it, to be honest with you. So I'm going to set this light up here behind this coffee beans so that you can see that when it comes on, but it won't cause too much trouble with the cameras. And I'm going to plug it in, and I'm going to flip the switch on. And as you can see, the light comes on, meaning we do have power. And if I now show you the app again, you'll see here, and I can't see that from my screen, it looks like -22, which means it's pulling 22.8 watts to run that power. And if I flip it off, you'll see it go back to 0, and I flip it back on, you'll see it use it again. Now what I'd like to do is take this to the extreme and plug something a little bit bigger in. I know, I've always got to push it. I've always got to do what I'm not supposed to do. And I honestly don't know how many watts this is going to pull. It may shut the inverter off on me. Then again, it may get hot. So here's what we're going to do. I'm going to clean all this stuff off the counter. That's another thing that building a... Now, it isn't a good practice when you're done to put all your covers and your little pretty caps and all that kind of stuff back on it. It makes things look nice. It also makes them a whole lot safer. But keep in mind, we still have a charge controller to hook up. And then once we hooked up the charge controller, hooking that up would be really nice. Now, we could talk a little bit about cable management. I've seen a lot of people, they drill little holes right here at the edges, and the cable goes behind the board, and it runs behind the board and pops out and connects here, goes behind this one, comes out right next to the battery, goes back here, comes out there, just pointing in that direction to where all the cables are hidden. It looks gorgeous. The only problem I have is I change things too often. And when I'm changing things constantly, the last thing I want to do is drill new holes, run new cables, and move things around. So let's take this, make sure it's off, and we're going to plug it in. Now, I do want to point one thing out. Something that I noticed a second ago, I don't know if any of you caught it. I'm going to plug the light back in here to the second plug. And I want you to notice here, this says it's 110 volts. It's pulling from 13.2 volts, and it's outputting 110 volts. This is DC, this is AC. Now, it is important on AC that in a pure sine wave that you have consistent and perfectly signed electricity. And devices like this that aren't sine waves, when you turn these on, you'll notice in order to compensate, the voltage here drops to 108 volts. 108 volts for a little bitty light is terrible, which means this, not only does it not run at 120 volts to start with, but it dropped 2 volts from a 12 or what was it, 26, 22 volt, 22 watt power spool. That's just, oh, you know what? I still have the app open. Where is it? There it is. Yeah, 22 watts, 22.89. So for it to drop 2 volts for that, it'll be interesting to see what happens when I flip this on. Are we ready? We're going to turn the first one on to low. And the voltage here dropped to 100 volts. This tells me that I would absolutely not plug anything in that isn't just a heating element of some kind, or a light, which a light is in essence a heating element. Now, this is an LED light, so it's very possible that that may not even come on. Now, it does, and it didn't cause, well, it did cause another voltage drop to 99. Now, this is starting to produce some heat. So we're going to see it is pulling 600 watts from that one burner. So that's pretty effective. It is pulling a pretty good decent amount of watt, but it's very disappointing that this cheap inverter is dropping voltage that dramatically. Because in order to get 100 watts at 600 watts at 100 volts, it now needs 6 amps. It needs 6 amps pulled from this battery, as opposed to what would have normally been 120 volts for 600, which would be 5 amps. So it's a whole amp. Now you can see with a small system, that's not very major. But with a larger system, it would make a huge difference. Now, this is very hot, so I shut it off, but it does prove that everything's working. Actually, I'm going to turn it back on. I'm going to show you another safety item that is a very cheap solution, and there are much nicer ones. And I've got a couple of videos from a few infrared, I keep calling them infrared, from heat thermal cameras. They are very cool. You could point it at this system, and I wish I had brought it, and I could show you all the wires and connections. At a bare minimum, this cheap little device is, I think, 15 bucks or so. I don't know that this one is in the parts list below, but I will add it tonight. But this should allow you to point to things, hold the button, and see the temperature. So here I can check this connector is 84 degrees. Here I can check this, it's 84 degrees. It's 86 degrees. So right here, I've got a 2 degrees temperature climb. I don't feel any difference. 2 degrees and 86 degrees is not a big deal. Come over to the bus, 84, 84. Right here at this connector, I'm seeing 92. At this one, I'm seeing 97. The inverter itself isn't warm yet. Whew, that's warm. That's running at 220 degrees. The fan kicking power out here is coming out at 105. And if I come back under this nice little cover, I'm back to 84. So you can see the heat is coming from this area here. Now, the fan to eject the heat is right here. So theoretically, what I should have done is turn this where it's off away from this fan blowing the heat directly across it. Now I'm going to shut this off so I can let this cool down so we can move this out and finish this. But you can see here, this little cheap inverter is very effective for a small little heating element like this. And when we hook up the charge controller, a small panel would be able to replace that energy fairly effectively in a single day. It also would be great for running a TV, but then again, you're talking about with a pure sine wave inverter, not this inverter. You plug your TV into this, first it's running at 110 volts instead of 120. Not a big deal, you got about 20% variance, which is probably about 20 volts, but under 100 is not safe for your devices. So, we've proven that this is all working. I'm going to unplug this, and I'm going to see if I can move this out of the way without burning myself or anyone else. All right. So now we've connected all of the parts that we've got here except the charge controller. So what I'm going to do is I'm going to turn this system back off, pop the breaker, turn the inverter off first, the important thing here is reduce the load as much as you possibly can. Then you turn the breaker off. You don't want to be flipping breakers or turning switches when you don't have to, when there's a huge load. Now that goes into the solar panels, and a switch to turn them off is much different from a switch to turn off a little DC connection like this. This is a solar panel shutoff. It is not a breaker. Now, will it blow up at over 1500 volts or 8 kilovolts? Yes, it will, but it's not made to be a fuse or a breaker. A fuse and a breaker needs to be like a T-class fuse or something along those lines. It's great for turning things off and on. There should be another breaker inserted if you want it. They have inline breakers, they have other breakers. But this one is, and notice that it has two temperatures for cold weather and hot weather, because obviously your solar panels, you need to know and adjust for those in the cold weather. But this, for two-pole series, which this is a two-pole series, is a 1000, I think it's the 1000, let me make sure. It is the 1000, it's the 1500 volt. The 1500 volt, and it supports up to 6 amps at 1500 volts. But at 300 it supports 320 amps. So it will pop, and it is IP66, meaning that it's waterproof, meaning this can be mounted outside at the solar panels so that you have a good shutoff. All right. Let's talk about charge controllers. This charge controller I bought at the very, very beginning to put into my RV. So when I was traveling, I could have additional power that wasn't connected on top of my RV. As you know, my RV has 3,700 watts of panels on the roof, but those panels are fed into the 6000 XP. And the charge controller in there takes care of them. This is extra power. This is what I use for extra power. What I really suggest is this one here, which is a much nicer version of the same thing. The link for this is included. The link for this is not, because I couldn't find them anymore. They're relatively cheap though. These were like 60, 70 bucks, and this I think is $90. But the major difference here is this one works with 12 volts, 24 volts, or 48 volt charging. but it also goes to 150 volts input and 35 amps output. Now, one of the big distinctions to make between the two is that 100 amps, or 100 volts, I'm sorry, of input, when you're trying to charge a 48 volt battery, can be very tricky, because you need to charge a 48 volt battery with its nominal voltage being 58 volts. You're going to need to charge at least 65 to 70, and you need a little bit of buffer to allow for the charger to work properly, to be able to adjust to the MPPT, the maximum power point. So as it's tracking, if you only have 70 volts coming through there, it can only look between 63 and 70 to see the best part to get that power out. But if you run this up to 150 volts, like I did with the solar shed, and you're running in 132 volts, now it can check for that maximum power point anywhere between 63 and 123, 130. And it gives it a lot more options. All right. You'll find the links for that also down below. But let's hook the charge controller up. I'm thinking somewhere around here. The battery is on the left, the PV is in the two in the middle, and the load is on the right. The load is for like a street light. If you were hooking this up on a pole and you had a small battery up on the top of the pole and you had a street light up there, you would hook the street light up here and you wouldn't need an inverter. This would be like a 48 volt light on your street light. We won't need this. But I also want you to notice that the placement of these screws is very significant. So you'll notice here, the positives are on the outside of the PV and the battery, and the negatives are together in the middle. Now, that is important to note because you don't want to cross the two positives. This can have 150 volts in it, and this could be charging a 48 volt battery. And when you crossed them, it's going to be a very, very bad day. So that is why I think they put these together. I honestly don't know that for sure. I suspect they put them together to prevent mistakes. I thought it was an evil task when I first saw it. And then one day I started to hook them up backwards and realized, ooh, that's really bad. Little strands stick out down here sometimes, and you don't want them touching, so that fixes that. All right, so let's get this mounted. I'm thinking that if I put a screw, look at that, my bit's still over here. Get used to that. You're going to be buying these bits by packs of 10. Just go buy the nice ones because the cheap ones will all break on you. All right, I'm going to put one here. And then I'm going to get another screw. Now, some people go to the extreme of measuring all this and then making their cables. And you can do that, and it does make it look really nice. That was not practical for today, but at some point I will show you how to put these lugs on the cables and how to shrink wrap them and how to make them. I mean, these are the ones I made, and these are the ones that were factory shipped to me, and as you can see, these look every bit as good as those. All right. Now, I have a shutoff switch here to shut the battery power from this off. I do this for a couple of reasons. You have two sources of power in a solar system. One comes from this side, and one comes from this side. If you can isolate this side and this side, you can make the stuff here in the middle safe. That way you do this, and nobody gets hurt. If you can't turn this off, and those solar panels are generating energy, this is going to be outputting power unless you trust going into the app and shutting it all off. So, I hear I have a question, or at least I think that's what I hear. So I'm going to run over to the questions real quick. All right, Christina, thank you so much for education videos. Maybe in the future you could show where and how is best to ground the off-grid system. This is going to have a major impact, and it depends on the system that you're hooking up. If you are in a van, these are usually vans, RVs, are chassis grounded, meaning that the ground wires for these items are hooked to the chassis. And that, most of the time, is the same as the negative. Even my RV, the negative is the chassis. Now, they run exclusive wires for high voltage and stuff, but the chassis is. So in most mobile instances, you're going to ground to the chassis. If you are working with a home system, the home system should have it grounded. The ground wires and the neutrals should be connected at one place and one place only, and that is the master panel box that comes in from the grid. The reason for this, and I'm going to take you to the whiteboard and give you because this is an excellent question, Christina, and there's a lot of confusion about this, and I don't claim to know all the answers of this. So if you have an unusual circumstance or something like that, you might want to seek some professional advice. But I will tell you what I know and how I understand it. When the grid lines come in, they come in with, let's say, 120 volts, 120 volts, and a common. You have a grounding spike, and I don't think I have I don't have a green. So I'm going to call oh, look at that, looks green. Yeah, that's green. You have a grounding spike, a grounding pole that's crammed into the ground outside. Now, in your breaker box, they will tie this bus bar and this grounding bus bar together. And usually this is done with a screw through the common one that screws into the panel and attaches it to the grounding one that's attached to the panel. But it should be only on that panel, only on the main one coming from the main line into your house. If you have a sub panel and let's say you pull this off here, this one, they should not be connected. The ground should be isolated and come back and connect to this one. The common should come back and connect to that one, and the positive and the negative should be independent. But it is very important that you understand in electricity, the purpose for the ground is to provide an alternative for the power going through you. In other words, you take a toaster and you throw it in the bath, and it hits the grounding wire attached to the house and the poles and the pipes, and it runs out that way, and it gets back to this box, and it pops the circuit breaker, or it pops the GFI if there's one of those here at the plug. Else, the only emergency exit is to give it a route here. It's there for emergency purposes, and most of the time it's only going to protect you from things like electric strikes. It's not going to stop you from getting electrocuted. The shortest route from what you have plugged in here is still going to be through you. And back to this where it will pop the breaker. But the ground is there, as I understand it, to hopefully isolate you from some of the external interference and lightning strikes and those type of things. It's not in a vehicle. Oh, that was the one, wasn't it? It's not in a vehicle, but on a plot of land. Okay, yeah. So So you're talking about this scenario. So I'm assuming that you have in this case, in the main panel, you should drive a grounding spike, and that grounding spike should be bonded to the common from your inverter here and only here. Everywhere else on your property, the ground should run back to this single point of ground and only. There should not be any other grounds. There should not be other poles. There should be nothing else. They should all come back to here. Treat them just like the positive wire. They all come back to this box and they all connect to this ground. Hopefully that answers your question, or at least as best I can. Grounding is a very, very tricky, and there are a lot of opinions about it, and the laws have changed a lot in the last few years. It used to think that you could run electricity, instead of having a common, you could run it back through the ground, and a device will run. Theoretically, the ground wire, this wire here, should never have electricity running through it, going or coming from the device, regardless, unless something bad's happening. This should be an emergency escape valve. That's what it should be. And you should think of it that way. Okay. Let's get back to the charge controller. And Christine, if you have any other questions, let me know. And anyone else for that matter also. Okay. So let's look at hooking this breaker so that we can shut the power off coming from this charge converter. Because if we have a bunch of panels hooked up, it's going to be pushing voltage into this battery. And if the battery is not there, it's just going to sit on these bus bars until you touch something, and then you're going to get hurt. So you can't isolate it without having a switch. So what I did is I built a couple of little wires here to connect these. And I hate to say, they don't fit perfectly, so I am going to put them in together. Now, typically, on PV and high voltage DC, you don't only have breakers on the positive side. In a PV box, in a shutoff, you will have both the negative and the positive, and you will shut both of them off. In the case here, we're going to do exactly the same thing. We are going to shut off both the negative and the positive. Because keep in mind, as our ground discussions a moment ago, that electricity is going to take the shortest path. And if your common ground or your common neutral is your chassis, then this, shutting off the positive or not shutting off the negative, could provide a route and could get you hurt. All right. And I got those backwards. Darn it. I need to make sure that it isn't backwards. Nope, it is. Even this switch tells me that it's backwards, and I did it anyway. And you can see here, when they are polarized switches, you will see the positive and the negative side of this. And you want to make sure that you get the connections on the right side. Because if you go to flip this switch and it's running high amperage through it, and you have those backwards, I've seen these things catch on fire. It's an interesting video if you ever see it out there. But these switches, they're great when they're used the way they're supposed to. But if they're polarized, you need to make sure that the positive is on positive, the negative is on negative. Back to my original biggest mistakes. Don't get the positive and the negative backwards, like I just did. All right, so negative on the right, positive on the left. Fortunately, the charge controller is exactly the same. So I'm going to put these two here. I'm going to run them up into here. Ah, it's perfect. Okay. Then I'm going to mark this. and that is a rail. So I'm going to take the rail, and I have them here somewhere. I bought a package of rail mounts. There's a link to these in the description. And I just bought this big package because every time I need to mount one of these dim rails, I don't seem to have one. And they're pretty simple. Just a little rail, and you just slide or it clicks in actually. And you just click, and it holds the switch, and we're just going to bolt this to the wall. So we'll put a screw here. I'm going to push these up in there. And as you can see here, as I was saying, I should have ferrules for these, and I don't. So I'm going to make them work. But it is a not ideal way of doing it. Now, normally I would cut the wires to fit in here instead of drill the dim rail in to match the wires. But since we don't have that ability here today, I am going to tighten down the positive and the negative here. And you can see here that both the positive and the negative run into the positive and the negative on. And I'm just double checking all of my tightness now. All right. Now we need to connect this to the bus bars. And we have this wire to do that. So what I'm going to do is I'm going to first connect this side. Now, normally I would get some straps, cut this wire to the right length, screw them to the walls, but we don't have that luxury, so I made this wire long enough to make sure it would reach no matter where we mounted it. And it'll be ugly, but it will work. Now, I'm not going to connect it to the bus bar first. I'm going to connect it up here first because I don't want to accidentally touch these together while I'm hooking this up. And so I'm going to pull this a little bit so that they're exactly the same width or length. Positive on the positive side here. Take this, I'm going to tighten it down. Negative on the negative side. I missed that completely. Not even in the hole. Twist and turn to get my head down there where I can see. Probably would have been a good idea to connect that before I... All right. Good and tight now. All right, now let's take this and let's just go here for this one. Now this wire is marine grade 14 gauge 105 degrees Celsius temperature, which basically means most people would say, well, that wire looks awful small. You sure it can support 20 amps? And the answer is, yes, it can support 35 amps. But only because I bought the marine grade tinned 105 degrees marine stranded wire. It's very expensive compared to normal wire. House wire for 110 volts, you can get for, I don't know, 15, 16 cents a foot. This is about 80 cents a foot. A lot more expensive. But it is also strand it so in a mobile device or in a place that gets a lot of motion and that kind of stuff, which I use mostly in RVs, then it doesn't break or come loose, and it supports really good high amperage, making it nice. All right. All right, we're here, we're here, we're here, we're here, and we're here. So let's do some metering. Let's find out. We've left the battery on. I've still got this open. So let's take the meter, which I heard beep earlier, and I wondered where the beep came from. Now I know where it came from. It's the meter shutting off. And we're going to set that meter down here now instead of up there, since all this is going to be live. I just want to check this to make sure we're still I did turn that on, right? There it goes, 13.2. I've got a problem with this meter where this cable comes loose and it starts reporting nothing. And it gives me false readings. I'm going to have to replace it and buy a new meter that doesn't do that, because it scares me when it does that. All right. So this one is green, meaning that it's off. Red, meaning that it's on. So since it's off, I'm going to turn this one on, and we're going to check the voltage here, 13.2, and notice the red on the red, the black on the black, and no negative. Often I will put them in reverse and connect them just so I make sure I can see the polarity is correct and make sure it shows up backwards. That way I'm sure, depending on which meter I'm using, that I understand what negative means. Okay, that means we can turn this on and everything should be functioning, except this is still not powered. Now, the Victron charge controller gets its power from two places. One, it can come from the battery. Two, it can come from the panels. That means if you have either one of them plugged in and there's voltage coming in, it will operate and it will run. Now, you can see here there's no lights blinking. So what we're going to do is we're going to turn it on. Boom! No, only kidding. All right. And we see here the light is blinking. Now normally that means that the Bluetooth is active and that you can get to it. Now, if this was a new device, you would need to log in through the Victron app, which looks a lot like this, or kind of exactly like this. And you would go under local devices, and you see here I got solar, what is that called? Solar, is that close enough? Want it over here? There we go. So you can see there, you'll click on the device and it will ask you for a password. I have already entered the password because mine's been configured for a long time. But you can see here, the voltage is showing up down here correctly. This up here would be the panel's voltage if it was panels that were providing the voltage. Now what's important here is when you hook it up for the first time on a new system, this voltage, it will auto-detect and adjust what it needs to. The PV is different. You have to go over, or the battery that it's going to charge is different. So you have to go over here, and this first drop down, and select the battery, and it'll force you to change the configure and tell you it needs you to confirm it and do it. It will be a very bad day if you put this on 48 on a 12-volt battery and you have a bunch of panels coming in. So you need to make sure you hook the battery up first, configure the device, change the battery charge voltage, then hook your panels up. If you do it opposite, you can get this battery voltage wrong, and it'll be a very, very ugly day. Now, it's a Victron device. It may not be a bad day. It may save you. They're very good and they're very smart. They're very proud of them though. Okay. All right, so this is on. Now, if we had panels, and the panels are all that we really have left. So what I have done is this would run to a solar panel. So what we'll do is we'll connect these so that we can plug it in. Now I like to put leads on these. I'm just going to throw this on the floor. I'll pick it back up in a minute. And connect these leads to the charge controller. And then these pigtails allow me to just plug in as I deem necessary the solar panels. If I'm at the solar shed, I can plug into it. If I'm out in the middle of boondocks in there, if I'm in the coffee trailer, I can just plug it into the panels that come from the roof. So this makes it very easy. So negative in the middle, as we discussed earlier. Now, here's a lesson for you. Shut the power off and test it. Do we have power here? No. Do we have power here? No. Do we have power here? No. I tested everywhere. I cannot stress enough the devices like this, especially in the all-in-ones, the leak of power from one side to the other is rampant. You cannot be too careful. It wouldn't even be so much to say, look, let's just shut the whole thing down and now let's finish working on this. It seems excessive until you reach down and grab the first set of wires that are live and pee your pants. And it only takes one, and then you'll start being like me. Now, it's never happened to me. Oh, that isn't going to fit. All right. These were crushed into that other one. Oh, maybe it's just nuts and screwed. That might do it. Think. There it goes. It is a very tight fit, which isn't necessarily a bad thing. And I think this one's going to require a little re-grounding also. How you guys online doing? Everybody okay out there? All right. Just wanted to check. I see there's still quite a few of them out there. That's good. If you need anything, just let me know. All right. Gonna hook this last piece up. If you've got questions, you can start lining them up. I'll be glad to answer them. If you don't, I got a few from online that people pass me. This does not want to go in. I don't think it's loose yet. Now, I'm not really going to be able to do anything but show you how to hook this up. Because you can't run solar panels inside. Now this is sticking out and it's ugly and it's not even going in. That other one I got to fit. I'd love to get this one to fit. I hate not winning. All right, let's try this again. There it goes. Woohoo! Got to celebrate the small achievements. All right. I don't like the way these screws are inside these holes. The new XS, the 12 volt to 12 volt charger, the video I did last week, I love the way they put a cap on this, and the way they put those connectors was fantastic. Okay, so now you have the solar cables, and they only plug in to the side that's correct. So we would plug this in and run it to the panel, and plug this in and run it to the panel. And then it would charge. We're going to turn everything back on. And it would charge the 12 volt battery. And I will make a short video for you guys, maybe this week, that just shows this actually charging. I can't believe I forgot to bring a panel, and wouldn't have made any difference. There's not enough light to charge it inside anyway. It's all rainy outside this week. But this, let's do some finishing touches here. Let's make it look a little nicer. So we got the bus bars that we can put on, the covers. Some of these covers are really nice. These are a little cheap plastic, but all you're really interested in is covering up the shock guard, the ability to accidentally touch things. All right, we're going to turn the light on. So we got some power being pulled. We'll pull these tools out of the way here. Put these screws back. Then we have our little tester for temperature gauge. So let's just run a few tests here. I don't suspect any of these will be warm. There's nothing up there running. And I will, when I do the test to show you this charging, I'll put the thermal camera on it also, and kind of show you that. We can figure out where the heat is. I'll hook up another 400 or 500 watts being pulled out of this, and we'll see where we can get some real heat. If the bus bars, the connectors, the screws where you've got them threaded in, the breakers where they're connected, the screw down clamp connectors, all of these pieces can get hot and cause problems. And especially if you're in a mobile unit. If you're in a fixed unit, it's not as bad, but it does happen. All right. We have, is there also a recommendation to put another breaker between the solar panels and the MPP charge controller? If so, how many amps should the breaker be? I suggest a specific shutoff for PV panels. This is a PV shutoff that is rated for 1500 volts or 32 amps. It is both the negative and the positive. So you theoretically, if we were to do this, actually I'm going to do it on this end so it's easier to see. This would run outside somewhere. Actually, let's just mount it. We got nothing. It's a good question. And I think it's worth just doing it right here. So we take this now I'm only hoping this wire will fit here. All right, so you have this shutoff. So theoretically, these pigtails could be long enough to run over here, and then this could run out to the panels. But it would not be much different than we run this through this switch like this, and this can allow you to shut the power off coming to the charge controller. This allows you to shut the power, charging power going to the battery, or keeping these energized when your battery's off, and this allows you to shut your battery off. So you have full control this way. Most jurisdictions require that this shut off be within 10 or 15 feet, I want to say, of your inverter. Meaning you have to have a shut off here. Most people, when they get that requirement, they've placed this box outside next to the panels. And that's not a bad thing because that allows you to work on them. I suggest you put 2 of them in. Put one inside where you can shut things off for emergency purposes. Put one outside where you can shut them off when you're going to work on it. But that's all there is for that. It's nothing serious. Can't make it look nice though. The wires run right down over top of all the other wires. But as you can see, it's basically just in line of the wires leading from your PV charger to your PVs panels. Hopefully that answers your question, Christina. All right. I hope everybody has got all of the information you were looking to get. What camera am I on, this one here? Yes. So I hope everybody has gotten good information from this. I did have a couple of questions from online I wanted to answer. Is it better to do parallel or series wiring? And what they're talking about is this piece here. And really what you need to answer this question is you need to understand how many volts can this accept, what type of battery you're trying to charge, get the voltage as high or to the best nominal voltage as you can get. For example, on the 6000 XP, it likes its PV coming in at 320 volts. That's where it's going to pull the most power. Now, you're not going to get that from one panel. I had 10 370 watt Aptos panels hooked up on my RV roof, running to one of the inputs on the 6000 XP. It loved it. It ran at about 340 volts and produced tons of power. But sorry, I'm trying to switch the screen where I can see see what you can see. Okay, so but I also had a shading problem. When I parked the RV, oftentimes when you go into an RV park, the back half would hang under trees, the front half would hang out. And I was losing, and let me just kind of show you what I mean. I was losing a lot of energy. The RV is shaped like this, and it has panels one, two, three, 4, 5, 6, 7, 8, 9, 10. So basically, the shade would come in and shade around this and knock out all 10 panels. So what I did is I isolated into 2 strings. I seriesed these 5 and these 5 and increased the power I was able to get from my system, because then when I parked under some trees and when one got shaded and the other. Now, was there a slight loss when we're sitting in pure sun from voltage drop? Yes. But the voltage drop from the top of my RV to the inverter is what, 12 feet? No big deal. Now, if I was running the panels 300 feet across a field to my house, it would make a much bigger difference. But I also wouldn't have alternating shading conditions. They would either be always shaded or not always shaded. Okay. So in this case, I went with all series, ended up going with a series within parallel. So it was 2 parallel series. So it was 5 in a series, 2 parallel. And that's what my RV currently runs on. And so there is no answer of which is better. You want to get the voltage by seriesing them up to the appropriate amount or as high as you can, because that's the least amount of drop in the wires, and it's easier in the smaller wire. But you don't want to do it at the expense of losing power because of shading issues. For example, and I know I give a bunch of for examples. Sorry about that. The solar shed, and you'll see from the video released this morning, has a layout of 4 panels on the roof, 3 on the sides, 2 on the back, and I run it 4 in series. These 4, because they're all facing the sun all the time. In the morning, these 4 hit the sun as the sun comes up. At solar noon, it switches to these 4. Now, the question becomes, why not just parallel all 12 panels and run them to the RV? Good question. First of all, I'm charging a 48-volt battery. And with a 48-volt battery, these panels only put out 120 volts for 4 of them, which is what, 30 volts apiece. So if I paralleled them all, it would get there to charge a 48-volt battery with 30 volts, and it would do nothing. Everything would be lost. Now, if I put 2, which is what I originally did, if you go back to some of the original videos I posted, I didn't have these 2 panels, and I did this series, this series, this series, this series, and this series. So it was 1, 2, 3, 4, 5. It was 2 in series, 5 parallel. Now the problem I had with this, and they ran at about 65 volts, just high enough to charge the lithium battery at 58 volts. But it left very little room for the MPP charger to be able to adjust for the 48-volt battery, so it couldn't find, and when a cloud would come by and it would drop just below 48 volts, I would lose a lot of power. So what I ended up doing is increasing them to 4 panels. Now, I was going to do 3 panels, 1, 2, 3, 4. But I didn't want to affect these panels on the roof like that. These are the big producers. So I figured, put the big producers together. But when you parallel them, it needs to be the same voltage, or very, very close. So that kind of is a very long-winded explanation to what is better, parallel or series the wire, and the answer is, it depends. Not the easiest solution. All right. Was there any other ones? Several of these have already been asked. Christine, I think you asked already about the grounding. Can I mix different solar panels? This is actually one that leads right into what we just talked about. Keeping in mind that each series in a parallel series needs to be the same voltage. that if I hooked up 2 panels that came out to 30 times 2 at 60 volts, and then I hooked up 3 panels at 30 volts, or let's say 25 volts, I would end up with either 75 volts if it was 3, and 50 volts if it was 2. Now what's going to happen in this case? The MPP controller, depending on the quality, might grab a combination of some of these, but what you can count on is the lowest common denominator is what you're going to get. What it can pull the most power of in 2 panels is going to be 50 volts, meaning everything from this extra 10 volts and this one above it is lost. If it's 3 panels and it's 75, it's going to pull the 60, and everything above the 60 to the 75 is going to be lost. Either way, there's going to be a lot of losses. That's why you hear, make them the same. Hopefully that answers that question sufficiently. One about tools, equipment, and things that it can run. This system, with a pure sine wave inverter, can run a refrigerator exactly the way it is designed. That is the short answer to that question. Can it run some power tools? Some, yes. A drill, probably. Circular saw, it's going to depend on the saw. Some of them it'll run. Some of them it's going to have a hard time starting. Some of them might stall out a little easier, simply because it doesn't have the amperage that it needs to make it happen. If you bump this to a 2,000 watt, and keep in mind these numbers on these inverters are fudged drastically. They're the maximum, the performance under the ideal situation, and the world is peaceful and everybody's having great world. It's not reality. I would say this is probably closer to 800 would be a safe bet. And I would say I would leave myself 20 to 30% on any inverter. Now my 6000 XP that's in my RV, when I get up in the morning and I start making my espresso, I make myself a latte every morning, and my wife's coffee pot kicks on, it runs at about 2975 watts. And it gets real close. Now fortunately that is one hell of an inverter, and it can handle it. It is a workhorse. But that's not true with all inverters. Victrons are pretty good, and the EG4 stuff is pretty good, but there are a lot of these cheaper ones that'll do just fine for what you're looking to do, but you have to leave some buffer. I hope that answered the question. I don't even remember the question. Can I mix? Oh, will it run power tools? Yeah, okay, so that should answer that question. All right, do I have any questions online from anybody? I haven't talked to you guys the whole day. Hello all. Is there anything I can show you? Any questions I can ask? Or answer? Would love to take a few questions, and if there's anything I can cover, anything I missed. I'm going to play with the sound effects. Again, I want to thank everybody for all of your subscriptions, your kind words, your fantastic week. It's just been, oh, look at the date on that stupid message. I can never get that message right. I'm going to fix it right now. While I wait for someone, if they've got any questions. Yeah, I think it's this one. It's not this one. It's got to be one of these boxes. Anyway, Hopefully I have answered all the questions. Hopefully you have all learned something. If you have, please take the time to like and subscribe at this point. It allows me to move forward. If you're going to be purchasing any equipment, please use the links below. They will help me out. They'll help me buy some equipment. I've got some fantastic plans planned for the solar shed. They are going to amaze you. They will probably answer a lot of questions for you going off grid that are looking to how much am I going to give away? Well, if you're still watching at this point, you deserve it. If you're looking to use big devices like washers and dryers and ovens, stay tuned to the solar shed. I'm going to get some really cool stuff built there, and it's going to take on a life of its own. And then we're going to transfer that to a house at some point, and I hope that all of you will be around for the ride, and I can't say thank you enough. You have all been wonderful. I really, truly do appreciate everything you've done. If there are no more questions, are we really at 2 hours and 15 minutes? We are. They're all nodding at me like, yes, please hang up. And I could talk for another 2 hours, but I won't do that to them. All right, guys. I'm going to fade to this Solar Live Sundays bander that I no longer use, and I'm going to set off some fireworks, and we're going to celebrate some more growth. Get me to 5,000 subscribers. Send it out to your friends. It's been a fantastic week. I love it. And thank you all for everything that you've done. And we'll see you next week, and lots of good posts coming up this week. Thanks a lot. I've got it on my video if you could cut the audio. And they all heard that. Bye, guys. And thank you.